Hi everyone. I am going to answer Wezary questions of first trial 2025. So first, I will talk about the statistics of the exam. In this Wezary exam, from 50 questions, 24 of them were repeated questions. So those questions are previously asked questions. 9 questions were modified, yani there was a slight change in the questions, and 7 questions were new questions. So this ratio almost every year same. And from these 50 questions, 26 of them definitions and conceptual questions, and 24 of them were problems. Again, this ratio always every year the same in every exam. And when we check the distribution of the questions, the chapters, we see that chapter 1, chapter 2, chapter 3, chapter 4, 7 questions were asked. And chapter 5, 6 questions. Chapter 6, 11 questions. And chapter 7, 5 questions were asked in the first trial of 2025 Wezary Physics exam. And now we will start the questions. I put the questions in section order. So from section 1, chapter 1, section 2, chapter 1, section 3, and chapter 2, it goes on like this. The first question is the question table question, which is asking about calculating the radius if delta theta, angular displacement delta as arc length is known, given. So how can we calculate the radius? It's about angular displacement title, and it is in this way, it is the first time asked just about angular displacement. In this year, we know delta theta is equal to delta S over R. R is a question, so I'm going to replace R and delta theta. R is going to be delta S over delta theta. So now let's calculate the R. Delta S is given as negative 1.2 meters. Delta theta is given as 180 degrees, but 180 degrees is not a second. We should convert it to radian by dividing 57.3. So when we divide it by 57.3 degrees, so we will get the answer as 0.38 meters. So it is going to be A. Next question is about angular speed, and angular speed questions. This question, the first time asked in this way, again, and then it was easier than previous year's angular speed questions. And so a car moves along a circular track with an average angular speed, which was omega average. What is the angular displacement of the car in 10 seconds? And delta t is given, delta theta is asked. So I will use omega average equation, which is delta theta divided by delta t. After cross product, we can get delta theta. So delta theta is going to be omega average times delta t. And omega average is 0.628, delta t is 10. Result is going to be 6.28 radian. When I check the units, all are given in revolution. So 6.28 radian is equal to 1 revolution. So angular displacement is going to 1 revolution. Correct choice is B. Question number 3. Here the following changes velocity of a car. Velocity is a vector quantity. We know that. And a vector can be changed by 2 ways. One of them is by changing magnitude. Second one is by changing direction. So I can change the magnitude of the velocity by speeding up or slowing down. So gas pedal speeds up the car or object. Brake pedal slows down. So both are correct. And what about changing direction? So steering wheel changes the direction. So when direction changes, velocity of the car also changes. So gas pedal, brake pedal, steering wheel, all are correct answer. All can be used to change the velocity of a car. And question number 3, as I said, it's the first time asked question. It is one of the chapter question. You can see that at the end of, as I remember, it's chapter 1. All points on a disk rotating around a fixed axis have the same. So disk is a rigid object. For rigid object, we know that all rotational quantities of every point is going to be the same. So angular speed is a linear quantity. It can change from for different points, but angular speed is the same for every single point on a rigid object. Angular tangential exertion also can be changed. So only B is the correct answer. This question is asked before 2021. A repeat question. Next question is about merry-go-round. A child on a merry-go-round undergoes 1.5 meter per second square tangential exertion. So AT is given. If the merry-go-round's angular exertion is alpha given, how far is the child from the axis? Child body follows a circular path. So it's a circular motion. And how far from the center the child means? Yeah, what is the distance from center to the circle? Yeah, and it reduces the question. So I will use AT and alpha relation in circular motion, R times alpha. So R is going to be AT divided by alpha. AT is 1.5, alpha is 1, so result is going to be 1.5 meters. So it is going to be the correct answer. Question number 6, previous last question. It is even it is the I think 2 times asked. This is the 3rd time. The unit of constant of universal gravitation, capital G, is. So we can use FG equation to get the unit of G. FG is equal to capital G, mass 1 times mass 2 divided by R squared. So leave G alone, transfer M1, M2 over R squared to the left side by flipping. So capital G is going to be FG times R squared divided by M1 times M2. We know Fg is Newton, R is meter, meter squared, kilogram, mass 1 kilogram, mass 2 kilogram, kilogram times kilogram, kilogram squared. So Newton squared per kilogram squared is D is the correct choice. And also this question number 7 is about centripetal force, and it's a force that makes a circular motion. It is the 3 times asked repeated question. A car traveling at 50 meters per second on a flat surface turns on a circle with a radius of 25 meters. The most direct cause of car's centripetal exertion. And what is the car's reason of car's centripetal exertion means? What is the cause of centripetal force? Because exertion and centripetal force are directly proportional and in the same direction, and their cause are the same. So for a flat surface, an object moving through a flat horizontal circle, so the force which provides circular motion is always friction force. Friction force between the object and the whatever the road is. So rectilinear motion of the car with a constant velocity, the force of friction between the tires and the road. So C is the correct answer. Question number 8, if the torque required to loosen a nut on a wheel has a magnitude of 4 Newton meters. So this is torque minimum torque needed to rotate, required torque. What minimum force must be exerted by a mechanic at the end of 30 centimeter range? This question is exactly the same question in the book. It's the asked the first time 2012, now 2025. So torque minimum is equal to, it is required to question, F minimum times D sine theta. So we'll find this, transfer this sine to the other side. F minimum is going to be torque minimum divided by D sine theta. So if I want F to be minimum, smallest value, so D must be maximum possible distance, sine theta must be 1. Yeah, the angle must be 90. So for minimum force, torque minimum is 40. Maximum possible distance is from x of rotation to the end of the range, 0.3 meter. Sine 90 is 1, which is the maximum sine. Result is going to be 133 newtons. So C is the correct answer. Next question is, in fact, this question it's about equilibrium conditions asked before, but slightly they changed the sign. That's why I made it a little the new question. Complete equilibrium requires translational equilibrium and rotational equilibrium. So translational equilibrium, net force must be equal to 0. Rotational equilibrium, net torque must be equal to 0. When both are provided, so then we can say that the object is in complete equilibrium. Question number 6 is the problem in the chapter of chapter 2. The first time I asked this problem. So let's draw this problem. A meter stick is supported. A meter stick means 1 meter long stick. I am going to draw 1 meter long stick. This is a stick of 1 meter long length. Supported at its 50 centimeters. So we are going to support it from midpoint, 50 centimeter in here. So this is 50 centimeter point. To the ceiling, yes. At 1.2 meter kilogram mass hangs vertically from 70 centimeters. So from 70 centimeters somewhere in here, a mass is attached. So now I'm going to attach the mass. Of course, I will draw this mass as a vector because it applies a force. This mass is 1.2 kilogram. Vertically from 70 centimeter, yes, and 0.6 kilogram mass is attached from 30 centimeter. From 30 centimeters, so somewhere in here, 30 centimeter. And another mass is suspended, which is equal to 0.6 kilogram. Now, both are at the same distance to the tension force. So in the rope, we have a tension force. And there will be a third mass to balance the system. Find the location where 0.4 kilogram must be attached to keep the stick in horizontal and rotation and translation equilibrium. Yani it's going to be balanced. So I will choose x of rotation as the location of Fn. Here is going to be axis of rotation. So axis. Distance to the, from force to the axis for 0.4 kilogram, this distance is going to be 20 centimeters. That distance is also 20 centimeters. And distances are 20 centimeters, so, but forces are different, so it's not balanced. If I want to balance it, that force, which I'm going to use the next object, must be in the same side of smaller mass. Yeah, it will be on the left of the suspension point or Fn. So somewhere, I don't know where, we have to suspend a mass. So randomly, I am putting somewhere. This mass is going to be 0.4 kilogram. And how many centimeters from x rotation to this mass? I will say it's x. I will find x. Now, both 0.4 kilogram and 0.6 kilogram provides counterclockwise torque with respect to the axis of rotation. 1.2 kilogram produces clockwise torque, so negative, positive, positive. Now I will calculate torque of each of them. So 0.4 kilogram will produce a positive 0.4x torque. 0.6 kilogram produces 0.6 times distance from force to the axis of rotation is 20. I'm not going to change centimeter to meter. And also I am not going to change mass to kilogram because finally, if I do that, when we make them apply the translation rotation equilibrium, they will cancel out. So that's why just for this question, you don't need to do that. I mean, but if you do, it's okay. It takes longer time. You can do that, but it makes more calculations. That's why I am not going to do that for simple short calculation. 0.6 times 20, it's going to be 12. So this is going to be positive 12 kilogram centimeter torque. And 1.2 kilogram, it's going to produce negative torque. 1.2 is the mass times distance is again 20 centimeter. 1.2 times 20, which is going to be 24. Negative 24 kilogram centimeter torque. So Fn produces zero torque because we choose this point as axis of rotation. So I'm going to apply rotational equilibrium. Rotational equilibrium, we know that net torque must be equal to zero. Yeah, and 0.4x, which is the torque of 0.4 kilogram. X is unknown, I will find it. Plus 12 minus 24 is going to be equal to 0. So then if I continue, 0.4 x is equal to this is 12, it's going to be 0. 0.4 x is equal to 12 kilogram times a centimeter. So 0.4, I know 0.4 is the kilogram, this is the kilogram, times x is going to be 12 kilogram times centimeter. So now these kilograms will simplify. If I divide 12 by 0.4, result is going to be 30. So distance, x is going to be 30 centimeter. Then I'm going to check. From 50, if I go to the left by 30 centimeter, this point is going to be 50 minus 30. Yani point is going to be 20 centimeters. So we have to suspend this mass from 20 centimeters. And question number 11, it is one of the chapter question again. It is asked before, but exactly the same as in the book, but this time they make a slight change in the end. So we can consider that this question is asked new type of question. But as I said, this question is one of the chapter question at the end of chapter 2. The combination of applied force and frictional force produces a constant torque together. Yani torque of applied minus torque of friction, according to the question, produces 34 Newton meter torque and rotating the wheel. The applied torque acts for 5 seconds. And for 5 seconds, this resultant torque is acting. 34 Newton meter is acting in 5 seconds. And in 5 seconds, we observe that angular speed changes from 0 to 10 radian per second. So from the initial part of the question, I'm going to calculate moment of inertia. Yani torque net is equal to I times alpha. Torque net is going to be, is given in the questions 34 in the question. I will calculate. Alpha is final angular speed is 10, initial angular speed is 0, divided by time 5. So this is 2. Then if I calculate, I is going to be 17 kilogram meter squared. This is the moment of inertia of this wheel. It will not change. Moment of inertia does not change if you don't change the mass and if you don't change the axis of rotation or shape. But second part, the applied torque is removed. If applied torque is removed, only friction will stay. Then friction will produce torque. Then torque of friction, I will calculate it. This was in the question in the book it's asked. I times alpha 2. I will say alpha 1 because alpha changes this time. I is 17. Alpha 2 is, it says that then the applied force is removed, the wheel comes to rest in 50 seconds. And from 10 to 0, it takes 50 seconds. Final angular speed is 0, initial is 10, divided by total time is 50. So I will calculate now how much is torque of friction. Torque of friction is equal to 17 times, it is going to be negative 0.2. 17 times negative 0.2, it's going to be negative 3.4 Newton meter. This is the one which is asked in the book. They ask in the book, what is the torque of friction? But this question goes one step forward, and this time ask, what is the applied torque? So I can use this. I know that applied force plus friction torque is equal to 34. And torque of applied force minus torque of friction because they act in opposite direction, is equal to 34 Newton. So applied torque is the question in here now. Okay, but friction is given, is we calculated negative. Wait, this negative is in here. I wrote, once again, don't write the negative. So it's going to be 3.4 is equal to 34. Transfer this negative other side. So torque of applied is going to be 37.4 Newton meters. So it is the correct choice. Question number 12 is the repeat question, 2013-2025. The product of the rotating object's moment of inertia, I, and angular speed, omega. So I times omega is angular momentum. So it is the correct answer. Question number 13, repeated question, 17, 20, 25. A solid sphere rolls at a horizontal smooth surface at a constant linear speed without looking what is the ratio of rotational kinetic energy to the total. Kinetic energy, rotational over kinetic energy, total is going to be C divided by C plus 1. C is for solid sphere 2 over 5. It's given here. 2 over 5 divided by 2 over 5 plus 1. So it's going to be 2 over 5, 7 over 5. So when we flip it, 2 over 5 times 5 over 7. Result is going to 2 over 7. So B is the correct choice. And question 14 is also repeated, 2021, 2025. A circus performance, juggler throws the two spinning clubs. One of the club is heavier than the other. Which of the following statement is true? Smaller club is likely to have large moment inertia. Smaller club means smaller mass. Moment inertia mass directly proportional. Smaller club will likely have smaller moment inertia. This is not correct. Ends of each club will trace out parabols. No, ends follow circles. If you rotate an object in air, its end follows circles. So this is not correct. Central mass of each club will trace out parabols. This is correct because you throw an object up into the air. It doesn't matter what kind of object it is. It will follow parabolic path. Question number 15, also repeated, 2021 and 2025. What is the restoring force for mass spring system? It is elastic force. So we are going to continue. Which of the following does not affect the period of mass spring system when it moves in simple harmonic motion? So 12, 14, 15, 16, 22, 25. And this question is very popular, as you see. Period of mass spring system, equation 2 pi m over k. Only m and k effects. Mass of the object and the spring constant effects. Spring constant effects, so it says does not. So this is not the answer. Mass is not the answer. Mass and spring is not the answer. Amplitude. Amplitude of the vibration does not affect the period of both mass spring system and simple candle. Question number 17 also repeated several times, 4 times repeated question, and it's smaller numbers, maybe numbers are changing, but the structure of the question is the same. The frequency of the vibration is 0.2, period. You know, period and frequency are inversely proportional. If frequency is given, we can calculate period 1 over 0.2, which is going to be 5 hertz, 5 paraseconds. So it's going to be 8. Next question. If the pendulum's length is 2 meters and the AG at this location 9.8 meters per second, how many complete oscillations does the pendulum make in 5 minutes? First, you should calculate the period of the pendulum from first sentence. Period is equal to 2 pi root of L divided by G. Then 2 pi, 2 pi is 6.28 root L. L is 2, G is 9.8. Then you are going to use your calculator. 2 over 9.8, it is 0.2 root of answer, multiplied by 6.28, it is 2.84. So period is 2.84 seconds. Now I'm going to use common definition of the period. Period is equal to total time divided by number of oscillations. So period is, I will calculate how many complete oscillations Does it make in 5 minutes? Cross product. I will calculate the number of oscillations going to be total time divided by period. Total time 5 minutes, 5 times 60. We should use the 60 seconds divided by period is 2.84 seconds. Now 5 times 60 divided by answer, it is 106. It's going to be 106 oscillations. So C is the correct answer and also the repeat question. Question number 9. A tuning fork produces sound with a frequency F. Wavelength in the air is 0.75. What is the speed? It is very easy question. You'll use the lambda times F equation for a wave. Lambda is 0.75. Frequency is 460. Multiply them. 0.75 times 460. Answer is going to be 345 meters per second. So B is the correct answer. Question number 19. There are P, Q, R, S waves, 4 waves. Which one is incorrect? We are looking for incorrect answer. Amplitude of the P and amplitude of R. We are going to compare P and R first. Amplitude is the highest distance from equilibrium to crest or equilibrium trough. P has a amplitude 2 units, as you see, 1, 2. R has the amplitude 1, 2 units, so they are equal. But we are looking for incorrect. This is not the answer. Amplitude of S is equal to Q, S and Q. Check them. S amplitude is 1 unit. Pardon, Q amplitude is 1 unit. S is also 1 unit because for the until here for 1 is also correct. 1 unit and 1 unit, they are equal. We are looking for incorrect. This is not incorrect. Wavelength of R is equal to wavelength of S. R and S, we will compare. Wavelength is, length of a complete wave. So 1, 2, 3, 4 units. Length of complete wave 1, 2, 3, 4 units. Yeah, 4 units for R and S. So also 4 and 4. This is equal, but we are looking for incorrect. The incorrect one is D most probably. D says that wavelength of S equal to wavelength of P, S and P. P has a wavelength 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units. But S 1, 2, 3, 4 units. So they are not equal. So this is incorrect. Wavelength of P is twice of wavelength of S. This question, the first time asked question by time. Now we will continue 21. It's the repeated question, 2022-2025. The figure shows a standing wave on a vibrating string. If the wavelength is 2 meters, what is the length? So it is, you can go by equation or you can go pattern. Pattern is in here, much easier. I know that. From length of each loop is 0.5 lambda. 0.5 lambda. 0.5 lambda, 0.5 lambda. So as you see, 0.5 plus 0.5 lambda, 0.5, 1.5. 1.5 lambda is equal to length. 1.5 lambda is given as 2, is length. Length is equal to 3 meters. So this is the correct answer. And next question, question 22. The distance between adjacent wavefronts, this is also a repeated question, 2020-25, is going to be from adjacent wavefront. From wavefront is compression to compression. So compression to compression, crest to crest, it is 1 lambda. A police car emits a sound of frequency 1113 hertz. This is the F. What speed must the car have? So source speed is the question. Source car is the source. For person standing person, we observer is 0. To hear it at 1200, again, F prime is going to be 1200 hertz. Speed of sound will be given. So equation for calculating F prime, we know it's going to be, let me write it in here, F prime is equal to F times V plus minus VO divided by V plus minus Vs. So as you see, F prime is greater than F. If F, first we know that Observer is at rest, so I am going to remove observer from the equation. But f prime is greater than f. To make f prime is greater than f, so this number, this sign must be negative because smaller denominator makes f prime greater than f. So this is going to be negative. So v minus vs. So then I am going to calculate what is vs, put everything in equation. F prime is 1,200. F is 1,113. V is speed of sound in air 345 divided by V 345 minus Vs. So I can do several ways from now on, but my way is generally replace them. 345 minus Vs is equal to 1,113 times 345 divided by 1,200. Let's calculate this. 1,113 times 345 divided by 1,200. It is equal to 320. And 345 minus Vs is equal to 320. Then if you calculate, Vs is going to be 345 minus 320, which is going to be 25 meter per second, which is B. And question number 24 is the first time asked. It says that all are characteristics of sound except, and which one is not characteristic of the sound? Mechanical wave sound, correct. Longitudinal wave, correct. Transwave, not correct. Of course, longitudinal wave is there. Sound travels in solid fastest, liquid faster, gas is slowest. Question number 24. Yeah, this is a question the first time asked, and also in the book we don't have this type of question, but similar question, but not this type. The civil level of sound waves produced by a trumpet is 80 decibel at 5 meters. This is beta 1, let me say that, beta 1 at a distance of T1. You can say that beta initial at the distance of initial. What is the decibel level at 50 centimeters? Yeah, what is B2? What is B2? Beta 2 at distance of 50 meters D2. So we know beta, how to calculate beta. Beta is equal to 10 log I over IO. And this equation can be written alternatively as the change between two sound intensities this way. Delta beta is equal to 10 log I2 over I1. Yani beta 2 minus beta 1 is going to be 10 log I2 divided by I1. So I need to know what is I2 over I1. After that, it's going to be easy. I2 over I1 is going to be equal, we know I and D inversely proportional, 1 over D2 squared over 1 over D1 squared. So now write them 1 over D2, D2 is 50, 50 squared divided by 1 over D1, which is 5 squared. Then I will find what is I2 over I1. Put it down. 5 squared over 50 squared, and 5 over 50 squared. 5 over 50 is 5 over 50 is 1 over 10 squared is 1 over 100. And 10 to the power negative 2. Now I can write in here I2 over I1, 10 to the power negative 2. Then delta beta, yani beta 2 minus beta 1 is going to be 10 log 10 to the power of negative 2, which is I2 over I1. I calculated. So then beta 2 minus beta 1 is given as 80. It's calculated as 10 to the power negative 2. It's going to be negative 20. So to get the beta, transfer this negative 8 other side. So beta 2 is going to be 80 minus 20, which is going to be 60 decibel. So 60 decibel is the answer. And a bat flying towards a ball emits a sound, echo. It's about echo reflected by the bat. This question is asked in one of the chapter 2 question, but just about the intensity. We know echo will have its questions like this. Echo has a less intensity than the original sound. Why they are asking? And they are asking this time from the question to question. So, but flying towards a ball emits a sound. The reflected echo received by the bat is echo always less intense than the original sound because as sound is expanding, intensity is decreasing. We know this. It's area of the sphere is increasing, so that's why the same energy is distributed on a larger area. For that, as in how something you get a problem with this flying forward, but that speed is so small compared to the speed of sound. For that, as in speed intensity quickly decreases as it's traveling. So then has a greater intensity than original impossible, less intensity correct. What about the frequency? In the case of approaching, frequency increases, doesn't get lower. So frequency should increase. Yani flying towards the wall, the frequency of the pitch detected by the bat should increase, but this is lower. This is not correct too. So only C is the correct choice for this question. The frequency difference between adjacent harmonics in a pipe closed at one end is equal to twice of fundamental frequency, because we know that closed at one end, frequency of the harmonics is F1, 3F1, 5F1, 7F1. So separation between adjacent harmonic is 2F1, 2F1, 2F1. So twice of the fundamental frequency. And question number 28, what is the fundamental frequency F1 is asked of 2.45 meter pipe and is given both at open pipe. So for both at open pipe frequency is V divided by 2L. So we're going to just straight and calculate. V is 345 2L, 2 times of 2.45. This is I think question in the book. It's exactly the same question. 345 divided by 2 times 2.45. Answer is 70. 70 hertz. It is A. Question number 29, also the repeated question. Calculate the magnitude of the magnetic field at a point of 0.1 meter D from a straight conducting wire to a direct current of 10 ampere. So B is equal to mu I over 2 pi D. So mu is 4 pi times 10 to the power of negative 7. I is 10, 2 pi, 6.28. Or you can just directly simplify pi's. 2 pi times distance 0.1. So this pi's will simplify. Answer is going to be C, as I remember. And next question, question number 30, which of the following calculates magnetic field magnitude at the center of circular coil? It's a equation mu I n over 2r. Mu I n over 2r is the equation. And in figure, wire 1 carries the electric current I1, creates a magnetic field B1, wire 2 carries the electric current I2, creates a magnetic field B2. What is the magnitude of the magnetic force acting on the wire 2? So this question is the question from the book. We set them in the classroom. Each wire uses one another's magnetic field. Yani when we are writing magnetic force on wire 2, yani F2, so length must be I must belong to second wire, length must belong to second wire, but magnetic field must be belong to first wire. And B1, I2, L2 is going to be answer. If you are going to write the force acting on the first wire, electric current will belongs to first wire, length belongs to first wire, but magnetic field belongs to other wire, and B2. It's going to be, if F1 is asked, it's going to be this way. If F2 is asked, it's going to be that way. And this question, first time I asked, in 2023, as I remember, the questions asked similar to this one. 4 charges, each following on a circular path in a magnetic field as shown, which charge moves clockwise. For clockwise rotation, so the sign of the charge and magnetic field must be non-similar. Yani, if sign is negative, So negative, then magnetic field must be cross. If sign is positive, magnetic field must be dot. So in this case, this happens clockwise. I make a table in the classroom. Yes, but if negative and dot and positive and cross meets, in this case, it's going to be counterclockwise. So we are going to check negative and cross, positive and dot, clockwise. Let's check the first one. Q1 positive. It's cross. It goes counterclockwise. Counter. Q2 negative and dot, again counterclockwise. Q3 negative and cross. Yes, it is. Negative and cross clockwise. Positive and dot also clockwise. Yani both Q3 and Q4 follows a clockwise path. A wire carries current east to west. So let's draw the direction set. So north, south, east, and west. Current, electric current from east to west. This way, electric current this way. Earth's magnetic field at the wire location is directed to the south to north. It goes on like this. B. What is the direction of the magnetic force? F is question. So we are going to apply right hand rule 3. Forefinger must point to north. Make your fingers, 4 fingers point north. Electric current must be west to the left. Look at your palm, it goes into the page. Yani into the page in this set is going to be downward to the ground, downward and towards the earth. Okay. And next question, an alpha particle, Q is given, moves at a speed of 2.4 times 10 to the power 6 meters per second, perpendicular to magnetic field. Strength is given. What is it? It's a repeated question. F is equal to Q, B, QVB. QVB, sine theta. Q is 3.2 times 10 to the power negative 19. B is 2.10 to the power of negative 4. V is 2.5 times 10 to the power of 6 perpendicularly sine 90, which is 1. So find the answer. 3.2 times 10 to the power of negative 19 times 2 times 10 to the power of negative 4 times 2.5 times 10 to the power of 6. Answer is 1.6 times 10 to the power negative 16. So it's going to be 8. Question number 35. According to Lenz's law, the applied magnetic field of the circuit is changed. The induced magnetic field attempts to make total magnetic field constant, yani unchanged. It's a statement in of the Lenz's law. Repeat question. Number 6. A coil with 25 turns of wire is wrapped around the hollow tip with an area of 1.8 meters square. Each turn has the same area as the tip, and a magnetic field is applied at right angle to the plane of the coil. If field increases uniformly from 0 to 0.55, then delta B is going to be positive 0.45. Just like this happens with 0.85 seconds delta T. What is the induced current? Induced magnetic field E. E is equal to negative N delta I, delta B, delta phi over delta T. Delta phi is because of the delta B change. Area times delta B over delta T. By everything negative. N is 25. Area is 1.8. Delta B is positive 4.55 divided by delta T, 4.85. So then, 25 times 1.8 times 0.4055 divided by 0.85. Answer is negative 29. Negative 29 is the correct answer. Which one of the following is not one of the recorded application? Until now, all questions about recording was which one is, but this time which one is not twice recorded. So furnaces, it will, car breaks the wheel, detecting metals will. This is the answer. Which of the following will increase the EMF produced by generator? You are going to use EMF equation for generator, Brownian equation. E max is equal to B A N omega. So rotating the coil will increase, will increase. In the question, this is one of the standard test properties, will not increase. It was asking, but they changed the question, will increase. So rotating the coil of generator faster, yes, it increases. Increasing strength of magnetic field increases the EMF. Increasing number of turns increases the EMF. So all answers are correct. In which of the following is back EMF induced? Back EMF induced in the opposite direction of the applied EMF. Yani you should connect the device first and battery. After that, you can talk about back EMF. So the device which is connected to the battery only is in here motor. C. Question number 40 is repetitive. It is 1, 2, 3, 4, 5 times repeated. Without a question, it is mutual inductance. A pair of adjacent coil has a mutual inductance M, and the current in the primary changes from 0 to 12, yani delta I is positive 12 ampere. Time intervals 440 milliseconds, which is 4 divided by 1000. It's going to be, as I know, 0.04. Let's check 4 divided by 1000. 0.04 seconds. Determine EMF E negative M delta I over delta T. Negative 0.9 times delta I is 12. Delta T is 0.04, which is going to be 0.9 times 12 divided by 0.04. Answer is negative 225 volt. 225 volts. Okay, I think in my calculation, in my all choices, there's a mistake. Let me do it again. 0.9 times delta I 12 divided by 40 milliseconds, 0.04. Answer is 270, sorry, negative 270 is the correct answer. An air core solenoid length is 10 centimeter, area is 50 centimeters square, 700 turns, is connected to 60 hertz AC source. What is the maximum current through it? So this 100 volt is the effective potential difference. Maximum current is asked. I am going to find it, but first I had to calculate in here Excel. To calculate Excel, I need L. L for solenoid is mu times n squared A over L. So let's get first. Mu is, if in here it is not written, but also we will be in the question. 4 pi times 10 to the power of negative 7 times n squared, 70 squared. Area is 50 centimeters squared, but you should convert meter squared by negative 4. Divided by length is 0.1. So 4 times 3.14 times 10 to the power of negative 7 times 700 squared. 700 squared times 50 times 10 to the power of negative 4 divided by 0.1. It is L is equal to 0.3, 0.031. And our Excel. Excel is going to be 2 pi FL, 2 pi 6.28, F is 60, L is 0.031, multiplied by 60 times 6.28. Result is almost 12.6, but 11.6 ohm. Now this is Excel. I will calculate now first effective current, effective potential difference divided by Excel, 100 divided by 11.6, 100 divided by 11.6 is 6.8.6. Then this must be multiplied by root of 2, 8.6 times root of 2 to get the maximum current times root of 2. Answer is 12.2. 12.2 amperes. So it is the correct choice. Question number 42 is the sample problem in the book. It's about RLC, parallel series circuit. In figure, find the reading of the voltmeter 4. We will find voltmeter across capacitor and inductor. If we total effective, yani 5, which is reading 45 volt. Resistance is 12 ohm. XC is 5 ohm. Let's see, XC is 5 ohm. XL is 14 ohm. So first you should get electric current. After that, you need to calculate the reading of without electric current, you cannot solve this. I mean that to get the electric current, you should first calculate the Z of the circuit. Z is equal to root of R squared plus XL minus XC squared. So Z is equal to R is given as 12 plus squared plus XL minus XC. XL is 14, XC is 5, which is going to be 9. Z is going to be, as I remember, 15 ohm. Let me do it again, the calculation. I'm sure on that. 9 squared plus 12 squared, 225 root of is 250. Correct. We got it. After that, we can calculate electric current. Series circuit, we know electric current is the same for all devices. That's why we need to calculate it. We total potential difference over total impedance. Total potential difference 45 divided by 15 is equal to 3 ampere. Now we will continue. Now I will calculate the potential difference across the C and L. There are a few ways, but I am going to use what is that across C and L? I know this C and L are opposite in direction. So if I want to calculate a position of C and L, it's going to be XL minus XC. So it's going to be XL is 14, C is 5, result is going to be 9 ohm. So then, if I want to calculate reading of the ammeter across CL, yani 4, this one, so V of CLN is going to be electric current of the circuit across CNL times Z of CLN. Electric current is 3, Z of CLN is 9, it result is going to 2 times 9, 27 volt. And 27 volt is going to be potential difference across the capacitor and inductor. Question 43 is about parallel connected devices. Calculate impedance of the corresponding circuit. So no XL, no XC, no R is given. So only way to calculate the impedance using the total electric current is equal to total potential difference divided by Z. So then Z is going to be impedance on the circuit, total electric current over total potential or total electric current. This is given, but this must be calculated. So first I have to calculate total electric current, which is going to be in parallel electric current of the resistor squared plus electric current of capacitor minus, not square after square after capacitor minus electric current of the inductor squared. Okay, let's calculate it. Root of 0.16 squared plus IC is 0.25 minus, so 0.25 minus 0.084 equals, then square it, plus 0.16 square equals, then take the root of answer 0.23. So I total effective is 0.23 ampere. Then Z is going to be total effective, which is 60 divided by 0.23. So 60 divided by answer, it is 260. 260 ohm is the Z of the circuit. Calculate the power lost. This is very popular Wezary question. 1, 2, 3, 4, 5, 6 times ask the same question. So power lost equation is equal to I sent squared over R. I sent is 12, R is 100. So 12 squared times 100, it is 14,400 watt. To convert the kilowatt, divide by 1,000, it's going to be 1.44 kilo, but 14.4 kilowatt. So it's going to be this. Question number 45. Which of the following transformer represents step-up transformer? In step-up transformer, we know that N2 is greater than N1, V2 is greater than V1, I2, if given, less than I1. But I not given, so we are going to use this first two. A, N2 is greater than 1, or V2 is greater than V1, V2 is less than V1, so this is step down, this is down. Okay, B, in B, N2 is less than N1, but it should be greater than, this is also down. C, V2 is less than V1, also down, step down, but D, N2 is greater than N1, this is up. This is the correct answer. Which equation correctly describes the condition for observing the first dark fringe? Equation for calculating the dark fringe, d sine theta is equal to m plus 1 over 2 lambda. For first dark fringe, m is going to be 0. So then d sine theta is going to be 0 plus 1 over 2, 1 over 2 lambda. Yani d sine theta must be equal to lambda over 2. This is the answer. 47. Because of the great distance from us, stars are essentially point source of light. But if two stars were near each other in the sky, the light from them would not produce an interference pattern. Because of the light of two stars are incoherent, not coherent. To produce a pattern, the light source mustn't be independent light sources. Every independent light sources produces cannot produce coherent and cannot produce an interference pattern. Question number 48. Double slit interference experiment is performed using blue light of hydrogen. Lambda is given. Fifth order bright fringe, m is equal to 5. Is at this angle theta. How far apart? So D is the question. So we know d sine theta is equal to m lambda for bright fringes. Then d is equal to m lambda over sine theta. M is 5. Lambda is 480. 6, but it must be converted to meter by -9 divided by sine of 0.578. Let's find it. 5 times 4,686 times 10 to the power of -9 divided by sine of 0.578. Result is the 2.4 times 10 to the power of 41 times 10 to the power -4 meters. Yani B is the answer. Diffraction is a property of which of the following? Sound waves diffract, light waves and sound waves, all types of waves diffract. All are correct. All are correct. All waves are changing direction as they are passing by the barrier or passing between a gap or around an obstacle. And question number 50. A laser source device that converts electrical energy, chemical energy, light energy. All answers are correct to coherent light sources. These are all about 2025 first trial Wezary questions. Every questions were slightly different and a bit compared to other, and the rest of them were repeated and modified questions. It was an exam as I expected. It was a normal exam. And some questions in this page, because they were repeated with different numbers, I didn't change them. Maybe you can see that some questions just by number is different than the original 2025 first try question. But as I said, the repeated questions for that reason, again, I didn't try again to change the numbers, okay?